We are doing MCQs of NCERT textbook. We don't have MCQ questions in continuity and differentiability lesson. Let us do MCQs of application of derivatives. Question number 35. Which of the following functions are decreasing on open interval 0 to pi by 2? Let us check the first function. We will take it as y. Y dash is minus sine x. And the given interval is open interval 0 to pi by 2, first quadrant. We know that in the first quadrant sin x is positive, but minus sin x will be negative. Therefore, the function is a decreasing function in the given interval. Let us check B option. Let y be cos 2x. Y dash will be minus sin 2x times 2, that is derivative of 2x. Now the given interval is 0 to pi by 2. X belongs to this interval. So 2x belongs to, multiply by 2, 0 times 2, 2 times pi by 2 is pi. First and the second quadrants. In the first and the second quadrant, sin 2x is positive, but because of minus 2, it will be negative. So this is also a decreasing function in the given interval. Now the third option, y be cos 3x. Derivative of this is minus sin 3x into derivative of 3x is 3. Now x belongs to the open interval 0 to pi by 2 and 3x belongs to, multiply by 3, 0 times 3 is 0, 3 times pi by 2, which is 3 pi by 2. This interval 0 to 3 pi by 2 is first, second and the third quadrants. In the first two quadrants, sin 3x is positive, and in the third quadrant, sin 3x will be negative. And the whole y dash, that is minus 3 times sin 3x in the first two quadrants will be negative, and in the third quadrant, it is going to be positive. So we say that in the given interval, it neither increases nor decreases. Now let us check D option. Let y be tan x. Derivative of tan x is secant square x. Because of this square function, it is always greater than 0, whatever the interval is. So definitely it will be greater than 0 in the given interval 0 to pi by 2. Therefore, this is an increasing function in open interval 0 to pi by 2. So the first two options are the correct options, A and B. Next question 36. On which of the following intervals is the function f given by f of x equal to x raised to 100 plus sin x minus 1 decreasing? F of x is x raised to 100 plus sin x minus 1. Let us find f dash of x. 100 times x raised to 99 plus cos x. Equating this to 0 and solving for x is not possible. We will check whether the function is increasing or decreasing in each of the given intervals. The first interval given is 0 to 1. Let us check the sign of f dash at half. Here the given interval 0 to 1, radians. So at half radian we are checking. 100 times half raised to 99 plus cos of half radian. Pi by 2 is 1.57 radians. And pi is 3.14 radians. So half radian is in the first quadrant. So cos of half will be positive. Both the terms are positive, so addition is also a positive number, which is greater than 0. Therefore, the function is an increasing function in the given interval. Now let us check B option. The given interval is pi by 2 to pi. Pi by 2 is approximately 1.57 and pi approximate value is 3.14. We will check at 2 radians. 100 times 2 raised to 99 plus cos 2 radians. 2 radians is in the second quadrant. In the second quadrant, cos 2 is negative. But when we compare it with the first term is a very large positive number. and cos 2 is going to be between -1 and 0, which is a very small negative value. Therefore, the addition of these two will be positive. In this interval also, the function is an increasing function. Now C option, 0 to pi by 2, which is 0 to 1.57. Let us substitute 1 radian. 100 times 1 power 99 is 1. Cos of 1 radian is in the first quadrant. Both are positive numbers, so total is also greater than 0. In this interval also, the function is increasing. But the question is asking for decreasing. Therefore, the answer is D, none of these. Question 37. The interval in which y equal to x square e raised to minus x increasing is. The function given is x square times e raised to minus x. Let us differentiate with respect to x. We will use the product rule. uv the whole dash is u dash v plus uv dash. Derivative of x square is 2x times v is e raised to minus x plus u is x square. V dash is e has to be differentiated first, then the power minus x has to be differentiated, which is minus 1. We have x e power minus x common. We get 2 from the first term and minus x from the second term. We will equate this derivative to 0. We get x equal to 0. We know that exponential function doesn't become 0 at all, whatever the value of x is. Now 2 minus x has to be 0, that is x is equal to 2. For the given function, the domain is minus infinity to plus infinity, and we got two critical values 0 and 2. Now we have three intervals, minus infinity to 0, 0 to 2, and 2 to infinity. We will check for the first interval. We have to check the sign of f dash. At minus 1 we will check. This is equal to, which is minus 1, e raised to minus of minus 1 is plus 1, 2 minus of minus 1 is plus 1, which is minus 3 times e, negative. It is a decreasing function. Now second interval, we will check f dash of 1. 1 into e power minus 1, 2 minus 1. The answer is 1 by e, which is greater than 0. Therefore, it is increasing in this interval. Now the third interval, f dash of 3. X is 3, e raised to minus 3, 2 minus 3, which is minus 3 by e raised to 3, less than 0. Therefore, it is a decreasing function. The question is, in which interval it increases? So, it is the second interval 0 to 2. D is the correct option. Question 38. The slope of the normal to the curve y equal to 2x square plus 3 sin x at x equal to 0 is. The equation of the curve is y equal to 2x square plus 3 sin x. You may miss that sin x. Do it carefully. It is 3 sin x term. We will find dy by dx 4x plus 3 cos x. Now we will find dy by dx at x equal to 0. First term is 0. 3 cos 0. Cos 0 is 1. So the answer is 3. This is slope of the tangent. We have to find slope of the normal. Therefore, slope of the normal is, change the sign and write the reciprocal. That is, we are using the formula m1 times m2 is minus 1. This is the perpendicularity condition. The answer is D option, which is minus 1 by 3. Question 39. The line y equal to x plus 1 is a tangent to the curve y square equal to 4x at the point. We have to find the point of contact. Let us take the equation of the tangent. Dy by dx, that is slope of the tangent, is 1. The curve equation is, it's a parabola, y square equal to 4x. Let us differentiate this. 2y times dy by dx is 4. Therefore, dy by dx is 4 upon 2y, which is 2 upon y. Now slope of the tangent and slope of the curve at the point of contact will be equal. Let us equate them. 2 upon y is 1. Therefore, y is equal to 2. Now we will find the x value by substituting in the curve equation. Y is 2, 2 square is 4, 4 equal to 4x, therefore x value is 1. We have to write the point of contact, write the x coordinate first, 1, 2. The correct option is A. Question 40. The point on the curve x square equal to 2y which is nearest to the point 0, 5 is. X square equal to 2y is a parabola. This is x square equal to 2y. And the point is 0, 5. We have to find the nearest point. Let us take the nearest point as x, y. So we have to minimize the distance between 0, 5 and xy. The distance has to be minimized. So the distance formula is root of x minus 0 the whole square plus y minus 5 the whole square. Now we have to differentiate this. To make our differentiation easier, we will square both sides. In maxima minima questions, we can square and do it. D square, I will take it as S, which is x square plus y minus 5 the whole square. In this equation, we have two variables, x and y. We will eliminate one of them. We can eliminate either x or y. I'm going to eliminate x square. X square is 2y. Let us differentiate s with respect to y. So 2 times dy by dy is 1. Plus power has to be differentiated. And then the base dy by dy, which is 1. We will equate the first derivative to 0. 2 times y minus 5 is minus 2. Therefore, y minus 5 is minus 1 and y is 5 minus 1, which is 4. Let us calculate the x coordinate by substituting it in the curve equation. The curve equation is x square equal to 2y. X square is 2 times 4, 8. X is plus or minus 2 root 2. So the points are plus or minus 2 root 2, 4. But out of the given options, A is the correct option. One of the answers is given. We have two answers here. We have another point on this side, x dash, y dash. Actually, y coordinates will be the same for both these points. Next question 41. For all real values of x, the minimum value of 1 minus x plus x square upon 1 plus x square is. We will take the given function as y. Let us differentiate this using quotient rule. U by v the whole dash is u dash v minus uv dash upon v square. U dash, derivative of the numerator, 0 minus 1 plus 2x times v. V is the denominator, 1 plus x square minus u is the numerator and v dash is the derivative of the denominator, which is 0 plus 1 plus 2x upon 1 plus x square the whole square. Let us open the brackets. Minus 1 minus x square plus 2x plus 2x square plus 2x cube. And here there is a minus sign. Minus sign has to be distributed for all these terms. 1 plus 2x minus 2x square plus x square plus 2x cube divided by 1 plus x square whole raised to 2. Plus 2x minus 2x, they will get cancelled. Plus 2x cube and minus 2x cube. Minus x plus x. Minus 1. Minus x square plus 2x square is plus x square. Minus of 1. Minus 2x square plus x square is minus x square. Upon 1 plus x square the whole square. we get 2 times x square minus 1 upon 1 plus x square, the whole square. Now we will equate the first derivative to 0. 2 times x square minus 1 is 0. X square minus 1 is 0. X square is 1. X is plus or minus 1. We have to check the value of the function at these 2 points, and we have to select the minimum value. We will calculate f of 1. F of 1 is 1 minus 1 plus 1 square upon 1 plus 1 plus 1 square. We are substituting in the given function. 1 upon 3. Let us calculate f of minus 1. 1 minus of minus 1 is plus 1, plus minus 1 the whole square is plus 1, divided by 1 minus 1 plus minus 1 the whole square is plus 1. The answer is 3, and we need the minimum value. Out of 1 by 3 and 3, the minimum value is 1 by 3. The correct option is D. Question 42. The maximum value of x times x minus 1 plus 1 whole raised to 1 by 3, where 0 less than or equal to x less than or equal to 1 is. And look at the given interval, it is a closed interval. And if the domain is a closed interval, and we have to find the maximum or minimum value, means it becomes absolute maximum and absolute minimum question. So here we have to find the absolute maximum. Even if the word absolute is not mentioned, because of the closed interval, we have to find the absolute maximum. Let us take the given function as f of x. I'm opening the brackets, x square minus x to avoid the product rule, plus 1 whole raised to 1 by 3. Differentiate f dash of x's power has to be differentiated first. 1 by 3 times x square minus x plus 1 whole raised to 1 by 3 minus 1, which is minus 2 by 3, times the base has to be differentiated, which is 2x minus 1. This can be written as 2x minus 1 upon 3 times x square minus x plus 1 whole raised to plus 2 by 3. Now we will equate it to 0 to find the critical values. We get 2x minus 1 equal to 0. So x is half. This is an absolute maximum question. The domain is 0 to 1, and we got one critical value, which is half. So we will find f of 0, f of half, and f of 1. So in the given function, we have to substitute. We will substitute here. F of 0 is 0 minus 0 plus 1. 1 raised to 1 by 3 is 1. Now half square is 1 by 4 minus half plus 1 whole raised to 1 by 3, which is 1 minus 1 by 4, 3 by 4 raised to 1 by 3. And f of 1 is 1 square minus 1 plus 1, which is 1 raised to 1 by 3, 1. This f of half is cube root of 3 by 4. Definitely it is going to be less than 1. So the maximum value is 1, and it is attained at 2.0 and 1. Here we have to find the absolute maximum value, which is 1. C is the correct option. Question 43. The slope of the tangent to the curve x equal to t square plus 3t minus 8, y equal to 2t square minus 2t minus 5 at the point 2 minus 1 is. X is t square plus 3t minus 8. Let us find dx upon dt, 2t plus 3. And y is 2t square minus 2t minus 5. Therefore, dy upon dt is 4t minus 2. We will find dy upon dx, 4t minus 2 upon 2t plus 3. Here t value is not given. 2 comma minus 1. X and y values are given. So let us plug in these values in the given equations. X is 2, which is t square plus 3t minus 8. From this equation, t square plus 3t minus 8 minus 2 is minus 10, equal to 0. Now let us substitute y as minus 1 in the second equation. Minus 1 is 2t square minus 2t minus 5. 2t square minus 2t minus 5 plus 1 will be minus 4 equal to 0. We will divide throughout by 2. 0 is t square minus t minus 2. Now to solve these two equations, we will eliminate t square. T square is t plus 2 from this, and t square is minus 3t plus 10 from the first equation. Now we will equate t square from both these. We get minus 3t plus 10 equal to t plus 2. 4t is 10 minus 2, 8. Therefore, t value is 2. Or you may solve the quadratic equation separately. The common solution has to be taken as t value, which will be 2. We have to find the slope of the tangent dy by dx at t equal to 2. Let us substitute t value here. 4 times 2 is 8 minus 2 upon 2 times 2 is 4 plus 3. 6 upon 7. B is the correct option. Question 44. The line y equal to mx plus 1 is a tangent to the curve y square equal to 4x if the value of m is. The tangent equation is this. Let us find the slope of the tangent dy upon dx, which is m. Curve equation is y square equal to 4x. We will differentiate. 2y times dy by dx is 4. Therefore, dy by dx is 4 upon 2y, which is 2 upon y. Slope of the tangent and slope of the curve at the point of contact will be the same. So we will equate these two dy by dx. We get m equal to 2 upon y. So y will be 2 upon m. We can use any elimination procedure and solve for m. Let us substitute y in the first equation. Y is 2 upon m, which is mx plus 1. And substituting y in the second equation, y square equal to 4x, we get 4 by m square, which is y square equal to 4x. From here we get x as 1 upon m square. Let us substitute this x value in this equation. 2 upon m is m times 1 by m square plus 1. 2 by m equal to 1 by m plus 1. 2 by m minus 1 by m is 1. So 1 upon m is 1. Cross multiply, m value is 1. Option A is the correct answer. Question 45. The normal at the point 1, 1 on the curve 2y plus x square equal to 3 is. Normal equation is given. We have to check which option is the correct option. We can substitute and check. This is the curve and normal is drawn at a point 1, 1. That means 1, 1 lies on the normal line. So it should satisfy the normal equation. So we can substitute and check. That is the easier method. Let us substitute the point 1, 1 in option A. 1 plus 1 is 0. No, it's not correct. 1 plus 1 plus 1 is also not 0. B option 1 minus 1 is 0. This is satisfied. And please check all the options when you use substitution method. 1 minus 1 is not equal to 1. So B is the correct option. Whereas if the point satisfies two or more options, say, then you have to find the equation of the normal by usual method. We first find dy by dx at that point 1, 1, from which we can get the slope of the normal and find the equation of the normal at that point. But here only one option satisfies the point 1, 1, so that must be the answer. Question 46. The normal to the curve x square equal to 4y passing through 1, 2 is. So here the curve equation is given and the normal passes through 1, 2. The normal is not drawn at 1, 2. The normal at some point of this curve passes through 1, 2. Again, this point 1, 2 lies on the normal line. This is the normal. It should satisfy the equation. So we can check which option satisfies. Remember, if more than one option satisfies the point 1, 2, then you have to find the equation of the normal. Okay, let us substitute 1, 2 in option A. 1 plus 2 is 3. This is satisfied. Then B option, 1 minus 2 is not 3. C option, 1 plus 2 is also not 1. Then D option, 1 minus 2 is minus 1, but here it is given as plus 1. Only one option is correct, therefore option A is the correct answer. Whereas, if the point satisfies two or more options, say, find the equation of the normal and check. Question 47. The points on the curve 9y square equal to x cube, where the normal to the curve makes equal intercepts with the axis r. Here points are given. We can substitute the point in the curve equation and we can check, because the normal is drawn at these points. So these points should be on the curve. Option A and B will satisfy the curve equation, whereas option C and D won't satisfy the curve 9y square equal to x cube. Now we have to find which option is correct, A or B. Here normal to the curve makes equal intercepts with x and y axis. Therefore, the normal line should be like this or like this. So these two lines are making equal intercepts. And these lines make 135 degrees with the positive direction of x-axis. Therefore, slope of these lines will be tan theta, which is tan of 135 degrees minus 1. So slope of the normal is minus 1. The normal cannot be like this, because if it is like this, then the intercepts will be a and minus a. They will have opposite signs. Intercepts are not equal in this case. The curve equation is 9y square equal to x cube. We will differentiate this equation. 9 times 2y times dy by dx is equal to 3x square. Dy upon dx is x square upon 6y. This is slope of the tangent. We will find slope of the normal, negative of its reciprocal. Using the formula m1 times m2 is minus 1. And slope of the normal is minus 1. We will solve this equation. We get y equal to x square upon 6. Let us substitute this y in the curve equation. 9y square equals x cube. 9 times x square upon 6 the whole square equal to x cube. 9x raised to 4 upon 36 is x cube. X power 4 is 4x cube. X power 4 minus 4x cube is 0. X cube times x minus 4 is 0. By solving this equation, we get x equal to 0 as one answer and x equal to 4 is the other answer. For this question, x cannot be 0. See the options. X coordinates are 4. So x is 4. Let us find the y coordinate by substituting in the curve equation. X cube is 4 cube, which is 64. Y square is 64 upon 9. Y will be plus or minus 8 over 3. Here negative y is not possible, so it takes the positive value 8 by 3. Therefore, the point of contact is 4, plus 8 by 3. Here the option A should be plus 8 by 3. So A is the correct option. 9y square equal to x cube graph will look like this. This is the shape of the given curve, 9y square equal to x cube. At the point x equal to 0, x-axis is the tangent, so normal is the y-axis. So intercepts of that normal won't be equal. And when x-coordinate is 4, y-coordinate can be plus 8 by 3 or minus 8 by 3. Only the normal drawn at 4, plus 8 by 3 will make equal intercepts on the x and y axis, whereas the normal drawn at 4, minus 8 by 3 the intercepts won't be equal. One intercept will be positive, the other intercept will be negative. That's why we are taking plus 8 by 3 as the answer. Therefore, the correct option is A, 4 and plus 8 by 3. Next, only one MCQ is given for linear programming lesson. Question 48. The corner points of the feasible region determined by the following system of linear inequalities. 2x plus y less than or equal to 10, x plus 3y less than or equal to 15, x and y greater than or equal to 0 are 0, 0, 5, 0, 3, 4 and 0, 5. Let Z be Px plus Qy where P, Q are greater than 0. Condition on P and Q so that the maximum of Z occurs at both 3, 4 and 0, 5. So let us calculate Z value at 3, 4 and at 0, 5. Z is, this is X and this is Y. So Z value will be 3 times P plus 4 times Q. And at point 0, 5, Z will be 0 plus 5Q. And they give the same maximum value, the question says. Let us equate them. 3P plus 4Q is 5Q. Therefore, Q is 3P. D is the correct option.